We'll pick up at domain and range, continuing on application. Have yourself a merry little absolute value day. The last thing we want to work through here is application and interpretation of absolute value. So we're just going to show you one place where this is used. Just to explain again, as we mentioned yesterday, if this were a wall and then a hockey puck was being knocked to the wall, the hockey puck would follow pretty much the absolute value. It would just follow the absolute value path right there. So it could model an actual path of an object, the hockey puck in this case, or it could model a distance problem. So watch this here. Notice that this guy's path in the boat, his path is pretty much a straight line. He's just going in a straight line all the way through here. So here's Lake Powell, which is on the border of Utah and Arizona. And Jay is riding in a boat from his friend's home in a neighboring state. So he's in Arizona right now, and he's going across the border and then going into Utah there and apparently going back home. The graph of the function d of t is equal to 30 times the absolute value of t minus 1.5. You don't need to know where that comes from right now. Just this is the graph of the function down there. Shows the distance of the boat in miles from the state line. From the state line. Assume the graph shows Jay's entire trip. So let's interpret what this means, okay? When he's starting out, which is right here, this is when he gets in the boat. In the boat, okay? And over here is when he gets out of the boat. He arrives at home. Okay? This right here, the vertex, is the state line. So, at first, how far away from the state line is Jay? So Jay, not Jared, is 45 miles from the state line to begin with. So that would be this section right there. And he ends up, coincidentally, 45 miles away. And his home is 45 miles from state line on the other side. So the question is, how far does he travel? Well, he travels 45 to the state line and then 45 miles away from the state line. So the answer here is he travels 90 miles. 45 miles to the state line, as if he's going here. I'm starting here at 45 miles away. I'm getting closer and closer and closer. I'm at the state line, and then I go away from the state line until I'm 45 miles somewhere up there. All right. The next question is about interpretation. So how does the graph relate to the domain and range of the function? So we look at the domain down here, h, and the range is here. Context says down here, the domain is how long it takes for him to travel. So the domain is time for travel in hours. And we can actually put a number on that, right? From here to here is where he stops. He gets out of the boat, and I'm going to say approximately 3 hours, only because I don't know for sure, but my guess is that's an accurate description. But next, how does the range? Well, as mentioned before, the range is all positive numbers, and this is the distance from state line. From the state line. At first, he is 45 miles, but he gets closer. closer, closer, closer until he's at the state line, and now he's moving away from the state line, so his distance is farther and farther away. By the way, what does the rate of change mean in this context? In other words, what does the slope mean for anything here? So if I wanted to know what the slope is right there, what part of the problem does that slope represent? If we look at the units, miles, so slope is always going to be the y divided by the x, which is going to be miles divided by the hour, which is his speed the entire trip. So you can calculate how fast his boat was traveling just by calculating the rate of change there. So let's take a moment and see if we can actually find the MPG. Now notice we're not going to deal with negative and positive MPG because the line is straight, turns out the MPG is the same. This one just means he's going towards the line, a state line, and this one means he's going away, but the steepness is going to remain the same. So let's just see here. If I did take this point right there and to this point right here, how much down does it go? Well, here's 30 to 15. So it goes down 15. And how much to the right does it go? It goes from 0.5 to 0.1, so it goes up a half. So let me write that down as a fraction. So my slope is down 15 and right a half. If I consider that double things, I get 30 over 1 with a negative. But we can ignore the negative because that just tells you the direction, in a sense, he's going. He's approaching the line as away from, so he's decreasing his distance. He's decreasing his distance. That's what the negative there means. So in the end, he is going 30 miles per hour. And interestingly enough, because the line is straight, it is straight until it bounces off. It's still straight. It is consistent, so he never slows down. It's kind of cruise control. Cruise control for 3 hours. Hard to do, so this is probably more of an average than an actual. And there we go. And interpretation. The next problem here, go ahead and take a few moments to work on this on your own, interpreting what does things mean. A cyclist is competing in a race, rides past a water station. So here's the water station. So going closer and closer and closer to the water station until she is done with the race over there. So go ahead and do some interpretation for that.